Hello, we are recording this session, and I know Raj is eating dinner or lunch or whatever that is he's doing. He's having a good time, and we should start discussion. So let me begin. Since we are just two of you right now with me here, I would like to ask you a couple of questions, like basically around how are we doing, and more importantly, focused on your thoughts in what is on top of your mind. I would like to address that a little bit for a few, and then continue our journey to finish off the discussion on Chef, and then switch over to a little bit of Ansible. So we've been doing quite a bit of Chef. I would like to complete that off, which I think two more exercises that we have to go through to finish this off. And then we start Ansible. We'll also focus more and more going forward on Docker, which is how containers are evolving. And there is a new thing come up in Docker, which is using the technology called Swarm. It is a part of Docker now, starting with the version 1.13, which is like 2 months old, roughly. And we'll also play with Kubernetes and more things. So and specifically not just about tools, but also applications and scenarios of users, how businesses use that technology, how a given application will get deployed on some cloud architecture. What does it take to accomplish users expectations? Like we have businesses, companies using it. No. Okay, I was not.
Oh, yes, now we can hear you.
I know. I was all this time I was just talking about, and audio was missing.
No, you started off and in between it cut off.
I see.
We heard the word swarm, and afterwards it stopped.
So that was a glitch. So I think now you should be able to hear me, see my desktop, as well as, so I was talking about Swarm version 1.13 is new. It is a part of Docker now. It used to be a separate thing. Now Swarm capability has been built into Docker. So we'll do some exercises, some new examples in this that I have just built for you. Docker machine we'll use. We'll also use Kubernetes, and more importantly, not merely focus on a bunch of these tools and technologies, but also think about how businesses, how users actually use applications, and then apply that in the context of some cloud and identify what kind of an architectural blueprint will be most appropriate for a variety of different application types that people and businesses make use of. And that will make it more meaningful in terms of actual use case. That's what I will intend to do in the upcoming remainder of, we have 3 + 8 days left. Today is the day number 6 for DevOps, and then we have 8 days for architecture. So those are the sessions left, and that's our overall plan that we intend to cover. You'll see more of it as we go along. So we are going to discuss a little bit of Chef to conclude that. And then we will switch over to Ansible, Docker, and other direction we'll take as we go along. So I think we now have a few more people. That we were missing all of you guys. We're just 2 of us. And so people have joined. That is nice. So I was briefly discussing about, what do we intend to cover as we go along. We have a couple more things on Chef, and that's what I want to cover off. And before I jump into that, I would like to ask you questions. The things that we have discussed in Chef up until now is these 2 modes of operation, the solo mode and the client server mode, Chef client, Chef server mode. Those 2 modes of operation that we have seen already. And you have seen Chef solo run by itself and do things in the fundamental difference in the 2 modes are, you provide your kitchen, and you have to somehow send the kitchen over to that machine that you want to configure. And in here, the machine will grab its kitchen directly from the Chef server. That's the idea behind usage. So subtle differences that you see, and already, you have to provide the kitchen to the box, to the node, whereas in here, the node will automatically bring the kitchen. It will download the kitchen from the Chef server. That's the fundamental operative difference. You know what kitchen is. Kitchen is basically a collection of things that express your desire, right? If you look at a classic kitchen example, you will have let's go see that. Where is that thing? Previous unit will have a ready-made kitchen. So we'll, yeah, that repository, by the way, here on GitHub, it contains a ready-made kitchen for this exercise. So you see that in our kitchen, there is a .chef folder. In that folder, there is this knife RB. It's a very critical file. It has references to some secrets. And by the way, hey, I just published my secrets and access key onto GitHub. Did I do that by mistake? No. These keys and access keys and secrets are dead. The token here is dead. And so it's a dead token I don't have to worry about. So by the way, please do not publish your keys like this. I'm just reminding all of you. And so that is the knife RB, which you put credentials. So if you're tomorrow going to use OpenStack Cloud or Oracle Cloud, you will be putting your credentials for that cloud like this in here. And that's how I want you to actually use the cloud of your choice. So for example, Shiv Shankar and his company prefers Oracle Cloud. So you should look for this gem called Knife Oracle. Knife Oracle, for example, and find out what that Knife Oracle Cloud does. And so let's go see. This Oracle Knife Oracle Cloud gem has been prepared by somebody else, not the chef company people, but it doesn't matter. Here's the gem, the knife plugin. What you need to do is put in an entry like this, and then bundle, or you can install it manually if you like, or configuration. You have to provide your Oracle Cloud username, Oracle Cloud password, your URI, and your domain, right? These are the 4 things you need to provide. These are going to be made available to you by the company that gives you the account. So you basically either sign up for yourself or you use a corporate account there. And then once you have these things put in the Knife RB, you should be able to use Chef with Oracle Cloud. This is a private cloud endpoint, by the way. That example that is coming up is a private cloud endpoint. So you can define it to be private cloud and make it true if that is the case. Now, I do not know whether your Oracle deployment in your Exelon company is a private cloud or you're using the Oracle public cloud. That you would know. And depending on that, if you happen to be using Oracle private deployment inside your company, you should include that flag and mark it true. And that way, you will be able to monitor, manage, and operate on your private cloud provided by Oracle for your company. Similarly, now we go forward. Here, you should be able to say something like Knife Oracle Cloud Server Create. It is very similar to what you saw here in the other examples. Where was that? Like here, Knife EC2 Server Create. Very, very similar, right? We'll do a comparison right now. So back in here, Knife Oracle Cloud Server Create. That command is very similar. Now let's see some of the other options here. Let's go look all of them quickly. Let me quickly come back to the same point. I'll just zoom through the whole thing. Okay, yeah. So yes. So what I was going to do is just quickly review that what it has, and basically now you can see examples of somebody trying to create a new Oracle Cloud Server. So here is one example. Let's go see what it looks like. Here is Atom Editor. We'll open it up and see what it shows us. In the editor, it looks like this. Now let's go make it big so you can see from a distance. And it is too big probably. So we'll toggle it. Now, after I toggle it a little bit, I'll clean up. The idea here is to understand. The first command is to create something, right? And then we have to choose an image. That image is the line number 2 reference. Then we have a shape, a host name, public IP, SSH user reference, SSH keys reference, identity file, meaning private key reference. There we go. So that's the command. Orchestration for user at domain.io test 1, 2, 3 started, waiting for it to complete. So that's the log. The log entry for your case for using Oracle Cloud will be something like this. Remember to use bundle exec. And Knife Oracle Cloud server create, and then you have to provide the image you want to use. Now, Oracle will always want to use the Oracle Cloud Linux, Oracle Linux image. So this is probably Oracle Linux, Oracle Enterprise Linux, which is basically a clone of Red Hat Linux, if I remember right, or maybe some derivation. So some derivative of that, but you can choose your image here. You don't have to use that exact image. You can use something like Ubuntu or Red Hat or Fedora. You have to come up with an identifier as to how exactly you will label these things. Like, like this is a precise way of referencing it. Like that, Oracle Cloud will tell you how to select something different than this. So you need to know what that image ID is. You have to provide that image ID right there and then put a trailing slash. In the shape, OC3, this shape, how do you decide whether it's OC3, OC2, or God knows what? You can figure out that part by running knife Oracle Cloud shape list. There'll be something like that, very likely. Something like this, knife Oracle Cloud shape list will give you a list of all the shapes available, shapes and sizes and some flavors. Basically, it's the flavor of the machine. Like you'll see let's do a Google search on this idea. So you will immediately see the result. Let's see what happens when you run this query. And so you will probably see the Oracle Cloud shape list. And so here is the list of all the Oracle Cloud shapes. What shapes are available? It will basically boil down to the name of the shape. This is the source code for that code that runs to get the information about shapes. So I'm reading the source code and telling you that it will basically decide the name Oracle has chosen, the number of CPUs, the size of RAM, and how many IO per second are required and supported for that shape list. So that's the output you will receive when you run that command on against Oracle Cloud installation. Let's see a couple more results. Here is a reference to Oracle Cloud integration. This is a news item, and they're talking about it, which is nice. Let's see what else we have in Oracle Cloud. Yeah, this should be also good. And so it might give you a shape list here. Shape is the shape of the instance you would like to create. So it says use knife Oracle Cloud shape list, just like I told you, that is to list the available shapes. Similarly, use knife Oracle Cloud image list to list out the available images. And comma separated list of Oracle SSH keys you want to attach to the machine. So this SSH keys reference is going to be a reference back in here. This SSH keys reference is the reference to the key that you have added to the Oracle Cloud, the public key reference. And this line number 8 is the private key reference. Very, very similar, by the way, will be your OpenStack. Exactly, almost on the same lines. It will be here, you have to say OpenStack. And by the way, by looking at this command structure, I am thinking, maybe I'm betting, this Oracle Cloud is probably OpenStack. That's what I'm suspecting. Let us see, Oracle Cloud, is it OpenStack? Oracle Cloud is OpenStack. Is it OpenStack based? Let's find out. There will be news about it. Yeah, looks like it. Click. So Oracle OpenStack. So what Oracle's cloud is a basically OpenStack deployed by Oracle and rebranded. That's what it tells me. I was looking at the knife commands, and through that I was able to like find similarities in what OpenStack does with what Oracle does. And looks like they are indeed based on OpenStack, as you can read from this page, which is on the corporate landing page for Oracle OpenStack Enterprise Ready Cloud deployments. And they are contributing to OpenStack for Oracle Linux and all that. So you see that Oracle storage, and basically you can read the same thing in much more greater depth if you go to this site, OpenStack. So you'll see very, very similar features and functions and procedure calls and commands, pretty similar to what you would see here in OpenStack is what you would see in Oracle OpenStack, because it is the same software, except they've modified a little bit to relabel the command Oracle Cloud as opposed to OpenStack. Oracle Cloud as opposed to OpenStack. That's the kind of changes they will do, and to make it look like their own. But It is OpenStack. They told you on the front page of the website. So there will be similarities in what OpenStack, how these commands will operate with Oracle Cloud and OpenStack, but just telling you that you should actually try this exercise, specifically this client and server exercise, multi machines, having a web server box and a separate database server box, having these two boxes separately constructed in a separation of concerns exercise that we did with two clouds, Amazon Cloud and DigitalOcean Cloud. And there is an example available for Azure Cloud. And I think Raj was trying that one, I suspect. And so I'll help Raj later on after the session. And in these two clouds, you have it already a video showing how to go about doing that. But I would like you to try Oracle Cloud, specifically Shiv Shankar. And all the Boeing people, I would like you to try OpenStack, pretty much like what I described here, this idea of using OpenStack. And then these commands will slightly change depending on your deployment. You can see that detail. You can find it pretty much mentioned here. In a new tab, you search for Knife OpenStack, and you'll find exactly what to do. And here's the gem, the Knife plugin. This plugin called Knife OpenStack is available. All you need to do is include that in your, they're using Chef Gem install. Don't do like that. Don't do like that. You're not using, remember, if you happen to land on this page, we are not using Chef DK. So don't follow the Chef DK examples. And this will be similar. You need to install in the gem file method. So we are not using the DK method. It's a slightly different method. So don't go that direction. It will not work in the virtual machine. It will cause trouble. So follow the gem file method of making a reference to this gem in the gem file and do bundle install, and then you will proceed forward. When you do, you will have to provide these 5 things inside your Knife RB. So you will have something like cloud.boeing.com, and then your 5000 V2 tokens and all that, the username, password, for tenant name, region name, and off you go. That's how you should do. And if you do not have SSL implemented, you have to make it insecure true, which is very likely if you're testing it out. Your company may not have implemented SSL quite yet. And if that is the case, make sure that you have to enable insecure mode so that it will allow you to actually connect. Otherwise, it will fail. If you have internal deployment, you have to make sure that these, or you have to read through this entire gem page, understand what they mean, and then construct your Knife command, something like this, Knife OpenStack server create. And now we'll go read the whole thing and see what it looks like. We'll copy that, bring it here. And this is specifically for people who are going to use OpenStack. So I'll construct this command, at least explain to you how you have to construct it. And so it will look something like this. OpenStack server create. Then you provide your username, your password, your API endpoint, which will depend on your company's choice, which can be something that look like line number 4. And then line number 5 is your flavor type. And number 6 is line number 6 is image type. S, this is a reference to a public key. Then your line number 8 is a reference to your private key. And line number 9 is the role that you want to add. So the web server role, for example. That's the collection of things that you have to look up and identify. And once you get to see the person who has set up OpenStack for your company, line number 4, and this endpoint, this username, password, they will provide it to you. They will also be able to give you these values of 1 and 13, whatever the image ID number is and the flavor size is, the public key that you provide and the private key corresponding to that. Once you have this thing in place and that you have included the Knife OpenStack gem in your gem file, then you have to bundle it. And then after bundle update, then you run bundle exec Knife OpenStack server create. And that's one command that you need to run. And that's how you will basically build 2 different boxes, one for database server, one for web server, and see your deployment succeed. That's what I suggest that you do in your example, in your internal private cloud, which is what we just discussed in these two things that we talked about, Oracle Cloud and the private cloud. And let's get back to where we were. So we were at this location in which we completed, at least I completed these two things, which is to create a separate web app server and a database server. We were able to do that. And there is at least one person among us who has done it. And that person is not here right now, but he has completed this entire exercise. So his name is David. He's not here. He built the whole thing. And he even joked about him selling WordPress software as a service. But that's a joke.
I was able to do this on the DigitalOcean.
Okay.
But on Azure and AWS, it went for a toss.
Okay.
Try something again.
Yeah, we'll try it again with me later on after the session, and we should be able to fix it. So there is Azure instructions. I think I want to move on to the next idea. And this idea is slightly different than what we have done in the past, which is, we have been using, this Chef server from the company that is renting it to us, and they give us 5 nodes under management. 5 nodes are very limiting. So it's not enough for us to actually make something meaningful, something large, something enterprise grade deploy. So that's why, it's good for experimentation. Now, if you're a large company and you may want to not pay them money for this, you can totally do that. If you don't want to pay money to the Chef company and still want to have Chef server, it is possible. Why would you do that? Because you can, that's one thing. Because it is open source, that's another thing. And the third thing is you save money. And fourth thing, you keep control over your Chef server deployments. You have also, as a consequence, you get the burden to manage it yourself. So there are benefits, there are pros and cons of running something on your own, right? You can, your own Chef server, create your own Chef server. And that Chef server will actually contain everything that you see, the cookbooks and recipes, environments, roles, attributes, encrypted data bag, and all these things belong in the Chef server. And then you can use that Chef server to manage a bunch of nodes in multiple clouds and all that. That's the picture I'm trying to draw here. Why would you do that? And the question basically is, gives you a sense of control. That you run your destiny, you control your destiny, you know what you're doing, and you therefore are able to do it because you can. Simply because you can. That's one way to think about. The other way to think about is because because you retain control. So here is this Chef server product, which is in open source, available right here in this location. And that is what we intend to take. The commercial version of the same product is available here that you have seen already, that you have used already, this manage.chef.io site. You've seen it before. So we are slowly, in this next exercise, we will go away from this thing, not use this anymore. Instead, use the open source version right here. It is available. And the pros and cons that you will see, and there are subtle differences in the way it looks and feels. The look and feel part, meaning the user interface part, this piece of user interface, the browser-based interface, is not open source. So what you see in the UI here in the browser, that part is not open source anymore. It used to be open source, by the way. So they have stopped giving it to open source. What does that translate to? So the Chef server we are talking about, it used to be an open source product. It is still an open source product. But in version 11, the UI was also included in the open source. In version 12, it is not. UI not included. And so it is still open source, by the way, open source. You can see that in here. Go to this location and you see the course. The source code is available for all the tags you can think of. The latest tag available is 12.12, maybe branches is 12.4, and a bunch of different branches are available. So I think we'll go with the branch number or some number. So the idea behind it will be, you will be able to use the chef server without the user interface. And honestly, we don't care about the user interface. Why? Because if we are managing like hundreds of thousands of nodes, we are not going to be messing around with this user interface and adjusting your nodes and maybe modifying some attributes here or changing the run list by clicking the mouse button and moving around these things. We are not going to do this by hand. Cancel. It is impossible to actually do this 100,000 times. Nobody I know can actually do it. Even if they wanted to, they'll fail doing it consistently. So how do you do that? How do you actually manage? You run it through command line. Like we have seen before in multiple cases, we would like to manage our chef server deployment strictly by command line. And if that is acceptable to your company, using open source based methods may be the right solution. Our goal in this program is to help you identify and decide for yourself as to what is the right solution. You can choose to go commercial and go pay money and have somebody else run it for you, or you can do it yourself. Since we have chosen the example, the first one, we chose to go to the commercial option and chose the 5-node limited version. We already seen what the commercial offering looks like. I would like to now run another exercise, specifically beginning with this version 11 of Chef server, to install our own Chef server and then use it in the context of that kitchen that we have before already. So here we have our kitchen that you have seen before. I'll go to the Chef repo and open in the editor. And in the editor, you will see that the Atom editor will open up, and I'll go to the Chef cookbook, and here is the knife RB, and all that detail is already mentioned. This reference points to the Chef server from the company that provides you commercial Chef server. And I would like to change this URL to some other machine that we control, manage, and we create. So this line should be going away. We'll kill that line, by the way, momentarily. We'll remove that line, replace it with our own Chef server. And then, as a consequence, we'll remove any limitations it has. So we can do more than 5 nodes, for example, and a bunch of other things. So to get to that point, I want to strike this line number 8 and replace it with our own Chef server reference. This currently points to the chef.io website, api.chef.io. That's where it goes to. I don't want that. In the next exercise, I want to do something different. So I will begin with installing machine with Chef server loaded. Installing Chef server is actually pretty darn simple. What we can do is install it the Chef way. And that is kind of very meta, where you use Chef to install Chef server. And so we'll do that. What I intend to do is use Chef solo, this mode of operation. We'll use Chef solo to install a Chef server on some box. So that's our plan. So our result will be looking something like, we'll get a box somewhere, a big fat box. And this fat box will have to have at least 4 GB memory. That's a requirement. It has some version requirement for Ubuntu. So we need to meet that requirement. And some specific version of Ubuntu is needed for Chef server to run. I think it is version 12. I'll go and check on the website. It is written down there. And on that box, once we get, we'll create a Chef repository with Chef solo. And in that repository, we will configure it so that it will install Chef server onto this box. And then this particular exercise will be over. And we will then, from that point onwards, use our Chef server. This becomes our Chef server at that point. And we can continue using this Chef server for any subsequent exercises. That's what our next action will be. We'll create a box, use a Chef solo exercise, similar to what we did the very first time, very similar, and use it to create our own Chef server. And then that particular exercise can go away. We don't need it anymore because the Chef server is now ready. That's the plan in this exercise, which is coming up. in this website here. So to set up Chef Server, we'll use Chef Solo to install Chef Server. How do you do that? Begin basically by creating a folder and creating a gem file. In that gem file, we will have these things. So let's go skip this particular repository that we have. We'll come out of that, make a new folder. We'll call it Chef Server. I think I should stick to the name I have chosen here. So the name I have chosen is My Chef Server in the Cloud. That's the name I chose. So let me put these two windows side by side and let us see if I can arrange that like this. And so here I have the two things side by side. Okay. And now I will use the name I have in the exercise and then go in there. And in that directory, I will open editor and create a new file containing this gem file. Like this gem file is what we will need to put in that location. What just happened? Okay, new, and this content that we have, save it as gem file. And this is the beginning point for a collection of gems to be installed so that we get the capability to run whatever we want. And so I'm going to save it and examine what it contains. Is basically, I'm using the knife solo gem. I'm using Burke Shelf and using Chef. So these three things together will help me use the solo mode of using Chef. So that gem file is ready. I can basically bundle it. When I bundle it, I'll get all the gems loaded up. That's what's happening right now. And it should finish up quickly. And then we will prepare our kitchen. You know, in the very first exercise we did, we created our kitchen by saying bundle exec, knife, solo, initialize a kitchen right here, right now. So init dot, knife, solo, init dot. That's what we did. And that is exactly how we will begin constructing the skeleton framework of a kitchen. So here is the command which we need to run, and that will construct a kitchen in our folder here. So we do that, and it creates a kitchen. And in this, what we have is a ready-made skeleton structure, which basically is empty right now. Now, having done that part, we'll proceed to adding a bunch of cookbooks we need. And these cookbooks are the ones that will install Chef Server for us. So in order for us to put these cookbooks, we need to put that in the Burks file. This Burks file has this reference to some line called api.burkshelf.com. I don't want to use that. Instead, I will delete that line and put this content, which refers to the supermarket. Because we want to go to the supermarket and get these cookbooks, the apt cookbook, the Chef Server cookbook. This cookbook actually installs Chef Server. There are some necessary ingredients for Chef Server. We'll get those and get the package cloud cookbook. So these are 4 dependent things that we need in order for us to get the cookbook for Chef Server. That cookbook, Chef Server for cookbook, will show up here eventually when we install Burke Shelf install. So we'll have Burks get the books for us, and we do that by saying bundle exec Burks install, and that will bring the books down. So the books are getting downloaded from the supermarket right now. The books are coming down, and when they do, you will be able to use them. By the way, there are some warning messages here. You can ignore them. They will very likely not show up in the newer version of the workstation. We have a new version of workstation. These warnings will disappear. And these warnings are not given to you, by the way. So they are warnings for the gem developers. So it's a notice for them. Right now, we notice that we have these 4 books that we wanted: apt, Chef Server ingredient, and package cloud. Those books that we called out in our prescription. This is what we prescribed. The books are now available via Burke Shelf. So I'll close it, proceed to the next step, which is to get a box big enough And in that box, we need to have 4 GB RAM and Ubuntu 12. You can get this very easily in some cloud. Basically, cloud is up to your choice. And by the way, I just figured out a new cloud I think you should look at, Indeed. The reason you should look at that cloud is because it is the cheapest cloud you can think of, and also gives you bare metal options. Bare metal. I just figured out, I'm starting to like it. It's called the Scaleaway Cloud, the scaleaway.com. Not Scaleaway, but just Scaleway. Scaleway.com. It is not free. There is no coupon yet, but I will eventually get a coupon for you guys. I'll talk to them and see if we can construct a coupon. The idea is €299 per month. It is cheaper than DigitalOcean and Vultr and all others I know of. And also, the machines that you get are of different types, meaning you can get a dedicated bare metal machine also here. This is a bare metal hardware. So you're not a VM, but you're getting a physical machine right there. The pricing for bare metal is pretty intense, pretty cheap, pretty low. Think about it. You're getting this is, by the way, ARM machine. So it's not your x86, but it works the same way, almost. €299, and you're getting an ARM, 4-core ARM machine with 2 GB RAM. Here, you're looking at €12, which is roughly about $12. Not that big a difference these days between dollar and euro. And so $12 per month, you get a 4 dedicated x86 machine with 8 GB RAM. And that is, I think, a brilliant choice for bare metal machines. You're not using virtual machines. You're directly running on the hardware, and you get that available to you on the cloud. This is a bare metal cloud, and also gives you VM clouds. So they give you VM options also, $6 per month, $9 per month, pretty cheap. And that is this cloud, which I am starting to like. It is based in Paris and Amsterdam. It is not in the US yet. But having said, we can construct this box that we want in any cloud that we choose, including Scaleway. But I'll stick to the DigitalOcean cloud. All of you have accounts there already and a coupon already in place. So I'll just stick to that, DigitalOcean, and log in and get our token. So it's the easiest to get a machine there. That's why I'm choosing. You can choose any cloud you like, including OpenStack and Oracle and Azure. And so create a droplet. I want to choose the droplet in the size 4 GB. And remember to choose the operating system should be 12. This one, 1204, 64-bit, click. And the size should be this one, $40 per month. That's the size required, without which it will fail. There's a minimum RAM required, it's 4 GB, and the Ubuntu 12 version. Then we can choose the location. I choose San Francisco, and I choose my private key, and call this my chef server, and create the box. So I have a box now. I'll get the IP address from here, and then I'll construct something which is basically a node reference in the nodes folder. That's what I want to create. And so that node I will create in a node reference in that folder. I'll save it basically in that location, and I'll give it a name. The name needs to be matching the IP address or the DNS name. Your choice. You know that. From a previous example, you have run Chef Solo. And so I'm going to name this thing ipaddress.json and put that in the node folder. And this is an empty file right now, but I have that file created here. This is the file that I will like to now populate. What will I fit there? I will prepare my DNA injection, basically. Like, what do I want this box to grow up and become? I want this box to grow up and become a chef server. And so here it is. This is my DNA injection. It will basically define the configuration parameters I need, and also the run list. The parameters that I need here are these IP addresses need to change and match what we have from the actual location, which is this IP address. So I need to copy this IP address, put that in the place of this and anywhere else, and replace. So I replace that. Now I have my DNA injection ready to be injected onto that little droplet. When I now run Chef Solo, what do you see will happen is that it will install Chef Server version 11 and enable the web UI. And we are calling it enable true. So it'll enable the web UI. A web UI is available in the open source for version 11. So that's what you look at first. And it's a quick exercise. So we'll do that very, very quickly. You will have a run list with apt. First thing, update the apt cache. And next, just install Chef Server. That's the mode of operation that we'll use. So I'm closing this, back to the write-up, which basically says, now you're ready to run. And we will do exactly that, is to run Chef Solo like this. And so the idea would be to go and run bundle exec knife solo and then bootstrap. Bootstrap what? Bootstrap this IP address, root at IP address. And root at IP address is this. So copy that and paste. So this command, which is bundle exec knife solo bootstrap the box, will actually bootstrap the box. It will look at this IP address and identify that the corresponding node reference is in the JSON file here, because the file name matches the IP address. So it will pick up this IP address and the corresponding JSON, take this configuration, understand that you have to install version 11 of the Chef server, and run the run list, which includes updating the apt cache and install Chef server. That's what you will see when it runs. And so I'll let it begin the run. It takes about 2 minutes to 3 minutes, and I will invoke. While it runs, I would like to point out a couple of things, which is the Chef server version is 11, but the cookbook version is not 11. So please note that. The cookbook version for Chef server is this 2.16. It is different from the version of Chef server that we are actually installing. This is the version of Chef server 11. Whereas the book version is different. It is 2.16. And I just want to point that out. We'll also be able to now, once this thing finishes, that we will be able to use this box as our Chef server. And so we'll need to use the IP address that we have, because we have not bothered to run it with a CNAME or a record created in the DNS. So we can just use the IP address directly. And that is what we need to be able to do next. And so this Chef server install is happening. It'll take a couple more minutes and we should finish with that. And at the end, we will have our Chef server ready. And when you visit that IP address, meaning this one specifically, in a web browser, you should see something that looks like the Chef server. And we'll open that thing and run it right now. As soon as this finishes, reconfiguration finishes, we will be able to go to that Chef server ourselves on a web browser here and open it like this. Let the reconfiguration step finish. Here, the reconfiguration is actually happening right now. So I'll let it finish, and then I'll be able to open this site where we need to go and see our new Chef server loaded up. That's what we'll see here. It is a big package, but it is doing it. So finishing up that action and waiting for it. And finished. So now we should be able to open our Chef server in this new window and say go. And I should put an HTTP in front and say go. And so here we have a warning. Do you know what this warning is about? And why is this warning there at all to begin with?
Non-SSL?
It's not on a known host.
Yes, and yes, both are true. It is not known host. This warning is because we are not using HTTPS, whereas Chef server is expecting us to use HTTPS. And so all these things are coming into play. You will see that, no. I want to open Firefox Developer Edition, not this, Developer Edition. Why? Developer Edition, that's what I want to open. So please open. There we go. So it's now going to open a different browser, and which will help us see the issue much better. And so here you're looking at the connection is not secure. This prompt is coming because the Chef server is by default designed to operate in HTTPS, but we haven't bothered to insert a HTTPS certificate in place. So it is complaining your connection is not secure. And we can either go to the advanced section and say, yes, I understand. So please add an exception. So I can say add an exception. And I don't want to permanently store it, but just temporarily say, okay, I confirm this exception. And so when I confirm, it will let me open that website, which is how Chef server looks like. And so here it is telling you that this is your Chef server and its administration, its login name is admin. The password is this. It just gave you the password and login name already up front. So I'm going to log in using that detail provided to me, admin and password, login, and off we go. So now it is asking me to change the password, right? The password currently is whatever it was. And now a new password I should provide. So I'll provide it a new password. I'll keep it complex enough. And regenerate private key. This private key is the same key that you may have seen before in an example that looks like, okay, it doesn't, not in this window, but maybe in another window you will see it. In the Chef repo exercise, you saw the Chef repo exercise, we had that. And you will immediately recognize what I'm talking about as soon as I show it to you. So this key is the private key that was given to us by the Chef server when we downloaded a ready-made zip file containing the Chef repo. That's what you remember. We were able to get a ready-made knife RB and a ready-made private key, and we created our own encrypted data bag and all these things. We were basically, you remember from a previous step. This is the private key that I'm talking about. That is what you are trying to reset in here, regenerate the private key. This private key will be responsible for communication between you and your Chef server. That's what we are regenerating right now, because it is, existing key will be deleted, a new key will be generated as soon as you save. So I saved it. And then it gives you the keys if you like to have. So here is the public key, here is the private key. You can download it from here. So that's one way to operate on. So it gives you the public and private keys right there for you to use. And this is the only time you will see the private key in this user interface. It will disappear after that. So user updated, please copy the private key as the user's private key. It tells you that. And then you can see that this is your classic Chef server with environments and status and roles and nodes and cookbooks and data bags and everything else that you already are familiar with, except this UI looks different. The other UI that you have seen before looks different. And it is different because the new UI is a newer version and it is not open source anymore. But this one is. So that's why it got installed by default. Now, what I would like to also point out to you is that you can also see a bunch of things that this thing installs by itself when it does. And you can see that by going to the site that says /version at the end. So you have to manually type this. There is no link for it. Type this. And here you will see all the things that got installed in the Chef server when it did. So you will see exact versions of Bookshelf, Bundler, and this and that, and all these things. Basically, the installed packages with a Git GUID for those things that constitute together your Chef server version 11.1.6. And you can see that detail as to what actually got installed. This is mostly for diagnostic purposes if you want to go and see. But having seen this step, what I would like to actually do is to disable the web UI. And this is just the way I recommend doing, because the web UI is not how you would actually use. And when you're not using something, why keep it active? So what I'm going to do is go back to here in the JSON file, which is our DNA injection for that node, and this Chef server web UI that I have, I will basically make it false, disable it. And as a consequence, what happens is my desire has changed, and I have expressed my new desire to disable the web UI, and I made it false. But merely making this desire, express my desire in a JSON file, doesn't actually implement it unless you run Chef. So you run it again, pretty much the same way, one more time. So when Chef runs again, it will implement your new desire. And your new desire is, I don't want no web UI, so please take it away. And that's what you will see happening, is that the web UI will get disabled, which is exactly what you want, because you're not going to use the web UI. And so that is what it is doing right now. It will do basically the same thing, except disable the web UI. So you will see that it won't work. It will say that, service unavailable or something like that. Some message will pop up basically telling you that this UI that you saw before, this UI will go away as soon as this run finishes. And so it finished, and it finished very quickly right now, because there was nothing to do much except to disable UI. So now bad gateway shows up. This bad gateway shows up because you disabled the UI, so it disappeared. Nice. Now that we have a Chef server operations in our operation, we can make use of it. So you want to be able to configure your knife configuration. Like, you saw before, this knife RB that you have is pretty minimalistic. Instead, I would like to have a fully configured knife RB that we can operate our previous exercise just like that. And so what I would like to do is to go back to the previous exercise, the Chef repo exercise, which is actually in a new terminal. So here we go, new term, no, cancel. New terminal, and come on, new terminal. Where is the terminal? I wanted a new terminal. Where did you go? Okay, I'll open a new terminal. Go to that old exercise called Chef repo. Open Atom editor. And in there you will find that this knife RB is fairly elaborate. And I want to strike this line specifically, the Chef server URL, and I want to change it. I can do that provided I know what the new value I want to put there. So you can get to that new value. The values that you will receive are going to be coming to you from the Chef server. That value is what we are trying to find out right now. So I'm opening a new terminal window and going back to the Chef server exercise in that window. So that exercise is available in this location called My Chef server in the cloud. And in there, you have to basically get to a point where you get those credentials that you want to use, and you want to place them in this file appropriately. So I would like to collect those things from the Chef server itself, for which I need to go to the Chef server. So I can go to the Chef server simply by typing SSH and then the IP address, which is available here. And once you are in the Chef server, you will be able to find, let me make it full screen so it doesn't come in the way. So full screen. And here you are on the Chef server box itself. On that box, you will find that there are these files that are important. You want to grab them and bring them locally to your workstation. What are these files? There is a private key there, this admin.pem. This is similar to the name.pem that you have here, very similar. There is also this file called chefserver.rb. There are these two JSON files, but then these two additional PEM files are also useful. Chef validator.pem and chef webui.pem. And what you want to do is basically grab these things and download it locally onto your workstation. You can bring them very easily without having to manually copy and paste. What you need to now do is come out of that chef server, back into your workstation. And in here, what you want to be able to do is identify your current folder structure, identify your location where you are. So you don't want to be in the wrong location. And you want to basically create a location where you want to place these things. So that location happens to be the .chef location. As you remember, .chef is where these things go. All the credentials go in that folder. So I created a folder like that. It already existed. So I need to go and check it if it actually is visible in the listing. And I see that it's there. So in that folder is where I need to bring down those files that you saw in the chef server. You saw these files over there in the chef server in that remote location. I want to copy those files and bring them here. How do I do that? Basically, this is a shortcut for you to pull those files and put it right in the current location inside this folder. And currently, if you look at that folder, what do we have? We have nothing except this knife RB, which is very, very minimalistic right now. So I would like to bring all the credential files directly from the chef server onto our workstation. Here we go. Could not resolve I did not type it properly. So let me construct this command properly in Atom editor. And it looks like this right now. And so I would like to change the IP address, which I did not. I need to modify the IP address here. We have it in multiple locations. So this IP address needs to change. It needs to match the actual IP address from the box. That IP address is available here. We'll go to that location, copy the IP address, bring it back to the machine, remove the word IP address wherever it is in 6 places with the actual IP address, and then run these commands. Now it will work. Without that, it was not possible to run with the name IP address. That did not make sense. So now,
Nilesh,
yes.
can you explain how you did the search replace in Atom?
I see what you're asking. So what you're asking is, how did you quickly change from this to this? Like, what do you do? Right? That's the question, right?
Correct.
Okay. So here's what you do. You first of all select the item you want to change. And then on Windows or Linux, you press Control D. How many times? Depending on how much selections you want to do. So you want to do only 3. So press it 2 times, 1, 2. So something like, let me go to Windows and then show it to you. So press it Control D 2 times, 1, 2. You get 3 IP addresses selected, right? You press it more, Control D, Control D, Control D, you'll select all of them. Now that you have selected all of them, you just replace. Oops, oops, oops. You copy from the source, like here. Copy from that location, and then bring it here and just paste. So Control V for that example. If you're using Macintosh, you should put Command D and Command V as opposed to Control, use Command. So I was actually using Macintosh, but talking about Windows, so I was pressing Control and thinking Command, and so it was ugly, but whatever. So you understood that, right? It's easy. You can do multi-line edits and multiple cursor. You can, it's a fancy editor. It's a totally fancy editor, and I love it. And it is open source. It is built on Chrome's engine, Electron, that you may have seen before. You should also study how Atom is developed if you like. It's on atom.io. Having said, these files that I wanted to bring from this chef server box are now locally available in our .chef folder. You can see them here. All those files you saw, admin, PEM, chef server, RB, this and that, those show up. These 6 files came down. They came from the chef server here that we built. Now that we have those credentials, they're basically credentials for us to use. I would like to now tell you how to properly configure this chef server for use in your company, in your organization, in your team. And so what you need to do is you need to modify that knife RB to work with your chef server appropriately, right? So we will begin configuring our knife configuration. And there is a command for that, by the way. That command is to bundle exec knife configure -I. And by the way, let me caution you, the first time you run this command, it will fail because it expects HTTPS, and we haven't put an HTTPS certificate there yet. So this whole thing, this entire block that you see in the write-up actually ends up with a failure. And that is expected when you do it first time. If you don't want to run into a failure, you should skip ahead and do this thing. But I would like to point out to you that there is going to be a failure right now as we run this command here. We are configuring our knife configuration, basically editing this file eventually so that it connects with our chef server as opposed to the commercially available chef server. So I'm configuring that chef server to work with our setup. That's the command for that. So we'll begin. It'll ask a series of questions for us. It says, you know what, there is a knife RB already located in that file, which is this file, by the way. Do you want to overwrite it? And I say, yeah, go ahead, delete it. I don't care. So give me the chef server URL for your chef server. So our URL happens to be this. So we'll say, okay, HTTPS :// IP address. That's our URL. So I'll go proceed. Now enter the name of a user. So I'll give my name, say Nilesh, for example. So this is going to be an employee in your company whose name will be Nilesh. And choose the existing administrator name. The existing admin name is admin. So you have to keep that name. Don't change it. Then here it says, I need the private key path, the location where you stored your private key for the admin user. The location happens to be this is where the key is. So we need to provide that key. And by default, it goes to some other location. It is expecting that you are running this command on the remote chef server, but we are not doing like that. We are running it locally. So we have copied those contents here locally, so we have them here. So we need to provide that path to that folder. We can do that simply by referencing our cheat sheet. This path is there. It is in the .chef folder, and it's called admin.pem. Similarly, there is a thing called validator client name. The name that we have chosen is the default one, so we'll not change it. The location of the validation key for the validator client is this file, chef validator. So we'll say .chef/chef-validator.pem. And then the path to the chef repository, or you can leave it blank. So I'll leave it blank. You select a new password for the Nilesh user. So I'm selecting a new password, and it fails. It fails because of SSL. It says, could not establish a secure connection to the server. You said it is HTTPS here, right there, HTTPS, but you did not provide a certificate. So how do you override? It tells you how to do that. It says knife SSL check to troubleshoot. Or if you know what you're doing, you can just knife SSL fetch and mark your chef server as trusted. That's what I intend to do. So I'll say bundle exec knife SSL fetch, and it will fetch the certificate and place it in our folder. I'll tell you where, in a file that marks our chef server as trusted. So we don't have to worry about HTTPS anymore. We can see that in this folder, that there is a trusted certificates and a certificate was copied locally. This came down as trusted because we fetched the certificate from an untrusted machine, marking it as trusted. And that is how you establish a quick and dirty method of establishing trust without having to get a proper certificate. It's very dirty. I don't like this method, but I just gave you because it's quick and dirty. You have to spend money to get a proper certificate, which you can, and there is an exercise for that. Without actually spending money, there is a new certificate authority available these days, and that authority gives all of us access to free SSL certificates for life. That certificate authority is called Let's Encrypt. Encrypt. And this authority is, as you know, backed by open source companies. And what it does is it is not only free and open source, it is also automated. And so all these people that you know of, like VeriSign and GoDaddy and a bunch of companies that provide certificates, all of them are going to be extinct pretty soon because of this company. And this is what we use in Cloud Genius. You will see that certificates provided to the Cloud Genius website are actually issued by Let's Encrypt. You can click and show and see they're issued by Let's Encrypt authority. And so that is what I recommend using going forward for every site, every service, everywhere, in your company, outside your company, public facing sites, internal sites, wherever you have, you need an SSL certificate, you should get it from here for free, open source, and get it automated. So every 3 months, it will renew your certificate for you, and you don't have to spend a dime on it. This is how you should go forward, starting from now. It's a fairly new thing, about a year or so. It is not built into this specific exercise, but there are other exercises where we use this. And I strongly recommend using it. It is, I think, the best solution available today. And it basically beats anything else that you can see outside. All these big banks and big providers that use your SSL certificate. For example, here is one. Even Microsoft.com, Boeing.com, they will all show you a certificate that is issued by somebody. And so here is a certificate issued by Symantec Corporation. So they pay money for that. They don't have to, but they're doing it because they already paid probably. But I'm just saying that it's a bad idea to use commercially provided certificates anymore. It doesn't make sense to me. Okay, having said, in the marking it as trusted basically allows us to connect to that chef server again. So I am going to repeat that step that I just did before, except do it quickly this time. So first configure our knife configuration one more time. And this time it will not fail because we have our certificates in order. So configure the knife configuration, delete my file that I have, and I'll say, yes, please delete my knife RB. What is the IP address of your chef server? I know it is this IP address. So I copy it and paste it. What is the name of the new user? It is Nilesh. What is the name of an admin user? It is admin. What is the name of the private key for the admin user? It is in this location. I hope I typed it properly. I cannot see it, but I'll check. Yeah, I typed it properly. Validation client name is correct. The location of this key for the validation client is, and this is written down for you, by the way. Don't worry about having to remember these things. You can see them on the website. The path to repository is blank. Enter a password for this new user. So I'm typing the password, and it says, again, failed. Why did it fail this time? Failed to authenticate as admin with key Invalid signature for user or client admin. Did I type it properly? Hold on, let me see. Why is this error? Okay, let me make it full screen computer and understand what's going on. I think I typed it right. Oh, I am probably not in the right folder. Am I? Yes, I'm in the right location. Okay, and so I will run that exercise one more. So repeat the last step one more time. So again, configuring the knife RB, delete the old one. Yes, I want to delete the old one, and then provide the URL for the chef server, which happens to be the IP address I have, which is in the browser here. Copy. And provide https:// IP address. Enter. Username of a new user, I will say Shiv. And admin user is admin. Admin's private key location is .chef/admin.pem, which is this reference I'm giving here, which is in the .chef location. That's what I just typed here. And enter. The validator's name is this. The chef validator's name is .chef-chefvalidator.pem. That's the name. And then repository is blank and a new password. Again failed. Okay, I'm not going to fail again. I'll look at this later on. I'll skip this part. I dislike when it happens, but something is going on that I'm not able to catch quickly. Invalid signature for the user or client admin. Signature invalid. That basically means this PEM file is invalid. Is the file correct though?
So Nilesh, I have a question.
Yes.
When the chef server gave us the private and the public keys, you did copy that. So are these the ones which it showed you?
Yeah, this is the one that we created, right? We can reconfigure the whole thing. What we can do is go and reconfigure our chef server, pretty much generate new key pair, and bring those key pairs down. That's the way to diagnose. So knife chef server reconfigure. And so I don't want to go do these things right now because it can be a little bit of boring thing for all of you. You will watch and I'll do debugging. That's not a good thing, good spending our time. So I will skip this specific exercise for now with a quick summary on what we just did up till now. I will resume this exercise later on with you. So we are, by the way, almost at the end of the exercise. What we need to be able to do here is to modify our knife RB in a fashion that matches our chef server URL. Will be pointing to the IP address from DigitalOcean Droplet. That's the essential change I want to be able to do, and also provide our private key there, as opposed to the private key that was given to us before in other exercises that you saw before. This private key reference you will receive, and I will be able to do this exercise later on. I'm not really want to waste your time in debugging this right now. So I will skip that portion. And this essentially allows you to create more users in your company. We have just one user right now, which is the admin user. We can create more users and pretty much use this chef server as our own chef server, provided the configuration succeeds, which it did not. right now. And I think key is somewhere is broken. We have to fix the key problem that you saw here in this step. It is complaining that failed to authenticate to this IP address because the admin with the key has this key is invalid. So we have to regenerate the key, bring it down again, and run the command again. It will succeed. That's what I'm betting, and I'll do this later on. Once you have that, you will generate a new knife RB file for your use that you can use in place of something like here. Like you have here, it will be using your own chef server URL in this location. As opposed to this IP, this name, you will have your IP address. And your private key will go here. So say nilesh.pem, something like that. That's the only change you will make. And then this configuration you have in your chef server exercise before will start working with the new chef server that you created for yourself. That's the change we will do. And when we repeat this exercise, I want to skip ahead, not save this, and basically mark this not done, but proceed forward.
Nilesh, I have a question.
Yes.
What is the chef validator key? What is it? What's the purpose of that?
It used to be in version 11 of Chef. It existed. Going forward, you don't see any references to it. So it is specific to the organization. So there was a concept of validation at the level of an organization or a company or classroom. In my example, you will see, for example, you will see this. There is a reference to this thing called, where is that? I think I saved it incorrectly apparently, but there was a reference to a classroom segment. That was the unit that required a separate private key for chefvalidator.pem.
Okay.
That version 12 of Chef has dropped it. So we don't have that concept anymore going forward. It exists in 11, not in 12.
Okay, thank you.
Cool. Now, once we have that, we can actually use that new Chef server to bootstrap and create our new web server, new database server, new WordPress solution, all of that, just like that, using your own Chef server. And basically that means that you have to push your kitchen to your new Chef server and repeat the exercise. It's just a matter of pushing your kitchen up to the Chef server that you created and then bootstrap. So it's fairly trivial to actually implement. But in our examples will not work because our Chef server admin PEM file is broken for some reason. So that these exercises will not work for me right now if I try them, because there's no point in executing them. So I'm skipping to the point which makes sense next, and which will be the other version of Chef server. That will be a different box. So this will be the version 12 of Chef server, slightly different. Version 12 looks different. In fact, it doesn't even have a web UI. The exercises operate very, very similarly. You create a folder called something, you have a gem file in there, you initialize your kitchen, then you bundle install and get these cookbooks. These cookbooks are slightly different again. For example, this book is the Chef Server Cookbook version 4. And so you get these books down from the supermarket. You will ask Berkshire to bring the books down. And then you will create another node for your new Chef Server version 12. This time the machine is going to be 4 GB and 1404 Ubuntu. It is not 12, but 14 that you have to make note of. And then you install version 12 of Chef Server. It's functionally very similar. And you proceed forward and you will have a new Chef server going. You can use now your new Chef server to install, use Chef Solo to install your Chef server in this one command. Bundle exec, knife, solo, bootstrap your server. This will create a new Chef server for you. And what happens is when I hit a roadblock like I just did, I lose track of what I have in my mind. So I'm just trying to recap. Give me a minute and I'll recap and proceed forward. When I lose track, I completely go off track. So let me recollect my thoughts. Maybe it's a good time to take a short break. I'll rethink my sequence and I'll proceed forward in the right direction without wasting time. So here we go, starting a timer right now. So timer, 10 minutes, and we'll start a break. And I'll clear up my thinking and proceed forward. Roadblocks, when I hit, it just throws me off completely. Sorry about that. It happens occasionally. Hey, can you hear me okay? Are you able to hear me?
Yes, I can.
Okay, good. Good. Let's go. Let's proceed. So, yeah, it hurts when things do not work out. And, it happens occasionally. The reason is basically sometimes beyond control. I really don't know why that admin.pem that I downloaded from Chef server, why is that invalid? I have no idea. And this, I don't, we'll figure out. But what I'm telling you is that I don't want to waste any more time on why this happened. So I'm skipping that section on those two sections we have, which is Chef server section, version 11, as well as Chef server version 12. In version 11, you have the ability to run UI. In here, you have the ability to add UI after you get a license. You look at, talk to your attorney, figure out what the licensing arrangement is, talk to the company Chef server, and they'll let you add the UI parts if you buy a license, or some licensing arrangement you have to make, and then you can add. Those methods are also described in the instruction for this particular exercise that is also provided to you, by the way. If you have a commercial arrangement with the company, you can do that. But I'm skipping both of them, by the way, right now. And I'll either cover them at the next time, or if there is interest on your part to further go in these segments, I will actually do it here live with you. But since the exercises are written down for here for you, those are modules number 10 and 11. Those two modules are corresponding to Chef server 11 and 12. Let me confirm that. Yeah, it is module 10 and 11. So it's module 10 and module 11. Those are the two modules that correspond to these two exercises. My plan is to skip them unless you want me to do it here in a live session. I will do it. My plan is to skip. And if that is okay, let me know. If you want me to cover it here, let me know. Either way, whatever you want, I'll do that. And for today, I want to skip ahead and move on to a different tool, which is the Ansible tool, which is very dramatically different from Chef, as you will see. It is my personal favorite tool, by the way, my current favorite, I should say. In terms of tooling and making things happen, this is what I currently like, better than Chef. The reason are obvious. You will see them. Why? First thing is that it is based on Python, which is my preferred language. This one is based on Ruby. Second difference is that this one does not require any installation. Whereas this requires you to install Chef on the box, which you want to run on the nodes that you want to manage. You need to install them either using the bootstrap command or using the prepare command. That's where you need to install Chef. And then when Chef runs on the nodes, that it will look up Chef server and get the books and kitchen and everything, and it will run itself and configure and do the magic. In Ansible, it doesn't require anything on the nodes. When I say anything, I should actually put an asterisk there. The asterisk will include, you expect that you have Python, which is a reasonable expectation. Almost every machine that I know of, except Windows, will provide Python built in. It's there in the box itself. As you initialize a new machine, just enough OS will include Python. And therefore, you don't need to add Python specifically. You also need something which allows you to connect to the remote nodes. And that thing is called SSH daemon that runs on the back end. And that is already available in almost every Linux machine, every Macintosh machine that you know of. Not in Windows, but we are talking about Linux, right, primarily. So if you enable these things, then, which are, by the way, already there by default, you don't have to install anything else to begin with, and it will just work. That's one of the reasons why I like Ansible. There are other reasons, which is it is very brief in the way you describe, very succinct. And I'll show you what I mean by description as to how you describe your desire. You describe your desire in form of a playbook, as opposed to here is a cookbook. When I say succinct, it reads almost like, you basically read and describe your desire just like you would do in a document or a specification. You basically write things down. I want to do this, that, and the other. And you write that down in a simple file. That is how you describe your desire. And you write these things down in a file called a playbook. This playbook file is written in a format called YAML. And what is YAML? YAML is described by what it is not. And so it is crazy. That's how it goes. So yeah, we got a vote to skip. I guess, yeah, I can relate to why you want to skip. I think we had too much of Chef, apparently. So David voted to skip, which is, I can totally understand. So we are skipping ahead to this segment, module number 12. And in there, I was describing the idea of YAML. So what is YAML? YAML is described by what YAML is not. And so here is YAML. What is YAML? Let's read the definition. It is written in black and white, described as YAML ain't markup language. And this is how the formal definition of YAML is. What is it though? So that's the interesting idea. So YAML is basically a human-friendly data serialization, blah, blah, blah. What does that mean? You write stuff in plain English and it works for you in a programmatic fashion. That's what it basically says, human-friendly data serialization standard for all programming languages. So it is not a language, by the way. It's a way of writing stuff. YAML is a way of writing stuff, writing things in a human-friendly fashion. And I think it's a pretty darn good way of writing. And I'll give you examples and you will immediately understand what I'm talking about. So YAML is not a language. It's not a markup language. What is it? It is defined by what it is not. And that is a recursive acronym. You may have seen other recursive acronyms like GNU, not DNU, GNU, which is defined as what it is not. And if you know what GNU is, it's a recursive acronym of what GNU is it is not Unix. Like here, where is the GNU? Yeah, here it is. GNU is not Unix. That's the definition of GNU. And so is YAML. And so what we intend to do is write in this YAML our desire, our specification in form of a document that becomes a playbook. So playbook basically is a file which has a file name .yaml, as simple as that. Some file name .yaml is the file that you will write in very, very simple English-like methods or descriptive methods, and Ansible will execute that and implement your desire. That's another way to think about. And one last one to think about and remember is that just like this concept of a chef server is this concept of Ansible Tower. Ansible Tower is not open source, but your company might have it. Since it is not open source, I'm not touching it. But it is there as a solution. There are alternative solutions to Tower that are open source, and they are Rundeck. And I just found out about it. And so here is Rundeck. Where is that link? Here, rundeck.org. So this Rundeck actually conceptually similar in function to what is Ansible Tower. Ansible Tower is a commercial product provided to you by the company called Ansible, which is now acquired by Red Hat. And this is the product available on free trial. And I think your company, at least Boeing has it, I understand. So having said, we will stay focused not on this product, the Ansible Tower product, not on the commercial product called Ansible, but instead the open source version of Ansible, which is already installed in your workstation, by the way. And so that is right here. This product is already installed in your workstation. You can find out about it by running the command Ansible. Where is that? Ansible version. Will show you the version installed is 2200. That is already available. And what we want to do is begin understanding how do we put this to use. So I'll now describe the usage scenarios of this tool, which is kind of sort of similar to the Chef Solo scenarios. Very similar. In that, what you have is this place where you sit and you have your laptop with you and you write down your idea, your desire. And you basically write that desire in a YAML file. This YAML file is called a playbook. And all you do is you target running this playbook against some machines in the cloud. It can be a machine in your garage. It doesn't matter where the machine is. But the idea is, whether it's in the cloud or your garage or your kitchen, you can, as long as you can SSH to that machine, you can run a play, or rather play the playbook against that target. And you can have, this is one mode of operation where you're sitting on your workstation and you're letting this remote computer play the playbook. That's one operation mode. The other operations mode is to actually send your entire playbooks and run it right here on the remote location. So once you have the playbooks here, the YAML files here, you will invoke them in the remote location directly as if they are running locally. That is another mode of operation. So two modes practically. One, that you run them remote machines locally on that target itself. That's the local run of a playbook. And this is you're remotely controlling those boxes, orchestrating those boxes, sitting on your laptop. So this is your office. And you sit here and you write down your desire and you play the playbook, and it will orchestrate on a collection of machines out there in the cloud. That's the other mode of operation. So this is a remote orchestration method. And the other here method is a local run method where you send the entire playbook collection to the remote location and you run it right there. So let's go back to this site in here where we have a little bit description. So what I'm describing here is quickly moving through is this person who is connecting to this box away from him at this IP address and is able to then operate on those boxes as shown in the picture. And I think I described some of these ideas already in my handwritten description. So I'm skipping ahead in this in this, but not making sure that I'm covering the items that are missing. So for example, there is this idea that I describe here is called a host inventory. I described to you what a playbook would look, what a playbook would actually contain. It's a expression of your desire. It is executable documentation. So you can execute it. It's a YAML file. It will run and implement your desire. And the other idea here is the host inventory. This host inventory is basically another file, another plain text file, contains a list of all the boxes that you want to manage. So you have here 5 boxes. You will put these IP addresses of these boxes in a simple file and call it the inventory file. That's exactly what it is. So you will have a file in a folder. So you again have a folder like a kitchen folder. You will create a folder or whatever. You can call it whatever you like. There is no specific name for it. But in that folder, you will have a folder where you will keep your inventory, another folder where you will keep your playbooks, and another file where you keep your Ansible configuration. That file has to be this name. And inside your inventory, you can have a bunch of hosts, which will basically be a text file containing a list of IP addresses of all the boxes that you want to manage. And the playbook folder is a collection of books that you will have in your playbooks folder. And this Ansible configuration is just one file, which is a simple short file. I'll show you an example and you'll immediately recognize what it's supposed to be doing. And this is how you basically construct your folder structure. And then you run Ansible on your target hosts. That's the idea. We'll get to that idea with an example pretty soon. So coming up, next unit. Where is that? The example. Yeah, so here is an example coming up. What we want to do is run our very first Ansible run. And so I will prepare a ready-made repository for you, which is given to you for you to use, and that is this. And so I want to be able to go to this machine and clone that repository, bring it down locally. It's available in this location. You bring it down, it comes down, and it's there. We'll go in there. It's called Ansible first run, and I'll open up in the editor to see what it contains. So inside that, you will have a bunch of files located. You have a file that I mentioned called Ansible CFG. And this file basically contains a list of things as to where they belong. So for example, I'm calling out that my host file will be a file called hosts, and it is this file. So I'm basically saying that, that's the file that contains all the target hosts that I have. And I will call it out like this. So my host file is a file called hosts. That is this file. And then I have a playbook here, which is this. And so let's go see that playbook as to what it does. And we'll understand that. It's not so long, actually. It's only 50 lines. And it's very sparsely written. So I'll elaborate on point by point to help you understand. It is very intuitive to read, by the way. And so it should not be a complex thing to understand. I'll elaborate on that idea. Let's see if there are any important files in here to read and understand. And yes, there is this file. And this file is the virtual host file that will be useful for us to configure our Apache server. So we'll make use of that file. Now let us understand what this YAML file does. This is, by the way, the Apache YAML, which is the playbook that I have placed here, ready for you. And in that book, it is written in a YAML format. The way YAML is written down is very, very picky about how it is structured. I would like to call out what that means. I just said YAML is very picky, and so is Python. It is extremely picky to indentation. Anytime you have something at the very first column, you have to really pay attention as to how many indentations are there. This number of tabs, basically, or spaces that you play in your file, that you have in your file, it is extremely particular in observing your logic of how many tabs or spaces that you have, how many indentations you have used in a given file. It is these two things, YAML and Python, are known for indentation issues. So I just want you to be paying very careful attention in how many tabs or spaces that you type. It is critical. You will notice that there is this H, where H begins. It begins at the after two positions. So there is a dash that begins at the very beginning, and then a space, and then hosts. That's how it begins. The next alignment of sudo is right below hosts. So it is very, very specifically aligned. You will see that there are two spaces here, or rather one tab. There is only one tab here, only one tab here, one tab here. So it is already done for you, but I just want you to be aware that you cannot randomly type things like here. Cannot do it. It has to be like this. Sorry, like this. It has to be in exact that location for YAML to be valid. You can validate YAML yourself by going to YAML lint and go to this site to validate whether your YAML is correct. And this is a lint tool to validate whether your YAML is correct or not. So you can basically take this YAML, copy it, bring it here, and see if your YAML is valid, and say go. It will say YAML is valid. And that's a YAML validator, YAML linting tool. It's just a tool for you to verify if your YAML written is correct or not. If there are errors in YAML, it will pop up, throw the errors right in your face. So that's YAML linting. Back here, we will like to read this now. So at the very top level, there is this idea defined here called hosts, which is the name of the host that I want to actually target. The name is Apache. My hosts are defined in the host file, and the Apache collection will be the collection that I'm referring to in my YAML. So I'll put these two side by side for you to really compare them. And so I'm moving them side by side right now. Here we go. So this is my host reference. Come on, move. Yeah. So here is my host reference here. On the right side, you see the host file open. On the left half, you see the YAML playbook open. I have the host reference referencing these collection of boxes, collectively known as my Apache servers. And in there, I have only one entry called localhost. I intend to play this playbook right here on this virtual workstation, just like we did the very first exercise with Chef. I was targeting my own box where I'm sitting. So usually you will have you sit here and you will target some machine out there in the cloud. That's the dominant usage. But as in every first exercise that I typically do, instead of targeting on a remote machine, I used to target locally right this box. So we don't even have to use a cloud. That's the scenario. So I'm going to run my playbook right against this target, which is where I'm running it. And it's all local run. And therefore, my hosts file contains a reference to the name Apache, which is a list of all the hosts that I have. And the listing contains only one entry, and that entry is localhost. You can have multiple servers here listed out as your Apache servers. And that is what this shows you, is the collection called Apache. You can have, this IP address and another IP address. Oh, sorry, the IP address was wrong. So here, another IP address, and like that. You can collectively create a bunch of machines, just put their IP addresses in there as a quick and dirty method, and target them together as your Apache collection of hosts. But for our beginning example, we are going to target only one. And that is going to be the localhost machine itself, meaning this machine itself. And that is what is defined in our host file, which is, Okay, stop moving. Why does it move? Okay, yeah. Close. And that host file reference comes from your Ansible configuration. So remember the couple of interconnects here. There is an Ansible connection that defines what your host file is, which is this file called hosts. Inside that file called hosts, we have a reference to only one machine, which is the local host. And then the playbook says, use these hosts, Apache. Escalate the permissions to become super user and say yes. Use some variables. For example, use the HTTP port 80. And the domain I would like to use is example.com. And then these are the two variables defined in lines number 6 and 7. Next, we begin doing some tasks. The tasks are basically actions that we would like in terms of declarations that we declare, not how you do it, but what needs to happen. It is defining not how you do it, because Ansible knows how to do it. You just need to declare, I need these things to happen. So the first thing I want to happen is to install two things. Those two things are lines 14 and 15. And I would like them to be updated to the latest versions. And also, before you run it, update your apt cache. So I'm saying that update apt cache, yes. And then install these two guys, 14 and 15, which is Apache and Git, and get the latest version. So when you run this part of play, specifically this portion of the play, which is beginning from lines 11 through 15, you will see at the end of this portion, Apache and Git are installed. But before that action, you will also see that cache is updated. So to illustrate that just this point, what I would like to do is delete everything else and keep it even super simple. Delete. Everything else below that, I would like to delete. Like that. And keep it really simple for us to understand what is going on. So it's a very short playbook. That's what I want to run. So I just deleted everything else in the playbook and I kept only this one action, which basically does install packages called Apache and Git. And this is how you describe what you desire in form of a YAML file that becomes your playbook. So back in our example, we want to run our playbook, and you can run the playbook pretty much directly on your machine like this. So I will run it. And I have deleted a bunch of entries, by the way, but just so you know that I'll bring them back at a subsequent step. What I'm going to do right now is I should find a solution to this movement. It keeps on moving. And so, yeah, in our folder, we have these files that you know already, and I have modified the Apache YAML file, which is showing on the left half of the screen. I've reduced this complexity of it to keep it really simple, and lines number 11 through 15 is what the focus is. And I want to run Ansible quickly to see what it does. And I can do that like this. It says Ansible playbook. That's the command to execute. Please run a playbook for me. The playbook name is Apache YAML. And please ask me my super user password. It will give you some deprecation warnings because newer versions of Ansible have avoided the word using sudo. Instead, they use the word become. So they will warn us for that. Immediately right now, you will see a warning coming up, but we can ignore that and actually proceed forward. And what I want to do is just run this simple, modified, cut down, bare bones version of beginning playbook. And our result that we have declared is I would like to have Apache installed and Git installed. And before you install these things, I would like to update the apt cache. So when I run it, it says, okay, give me the password. The password, as you know already, is Cloud Genius. So I give that password. It says deprecation warning. Instead of sudo, use become. Instead of sudo user, use become user. and make sure become method is sudo. This feature will be removed in a future release. So right now it is supported, it will work, but they're giving you the deprecation warning, which basically boils down to you changing the sudo to become. And you see that the play started. It says task setup. I'm going to run it on localhost. Install packages. What do you want to install? This item and this item. So it did. And you're done. Now, do we have Apache now? I bet you do. How do we know? We can do ps-ef. And it's there. So Apache is now available to our machine right now. Do we have Git? Obviously, we have Git. So we have seen it. We had it before to begin with. So in this simple example of a cut down version of a task, we just concluded one task. I would like to now add the remainder items. So I'll bring them back. In this file that I deleted, I'll bring them back to how it was to begin with by doing a git reset. And now we have all the things back. We have finished this step. This task is already done, by the way, as you know already. So now other tasks include enable Apache. So the idea would be to define a name, and here you can do whatever you like. You can call it you can write the same thing in something like another language, like instead of enable Apache. This is basically English language. You can write whatever you like. Basically, that's what it means. And the actionable part is service, Apache 2, state is started. You need to start it. So declare that the result will be in a started state, which means if you by accident disable Apache, it will be started again if you run this play. Enable mod rewrite. This is a module you want to name. The name of the module is rewrite, and you want to make sure that it is present. So that Apache module will be installed if it is not there. And when you install a new module, you want to restart Apache process. So you notify a separate segment at the bottom. There is a handler to restart Apache. And that is what you would do when you install a new module here, like rewrite. You're basically notifying Apache module restart to restart the Apache process. And the state is what you declare. You don't tell it how to restart. You just declare, please restart. I would like you to be restarted. That's what this state declaration is. So it is very declarative in nature. You define what the outcome should look like, and there it goes. You define that this is the handler, lines number 48 and 50. This is what I would like to do. This is my desire, is that I would like you to be restarted. That's 48, 49, and 50. The actual actionable line is 50. 48 is a definition of the handler, and 49 is just a name in English language. So as you can see, the comparison now, if you compare this with what we did before in Chef, you are very succinct in a very brief fashion. You're describing what you want in terms of a result that you want to accomplish, and are able to actually accomplish those results by becoming by writing tasks like these. So we have this task called install packages, another task called SDF, which basically does Apache started, another task called enable mod rewrite, which is just a name, English language. This is English. You can do whatever you like here, like this. And the action will be present. For what? For the Apache module called rewrite. And when you install a new module, you restart Apache. Next one, we are going to make Apache listen on a port that we have defined already in upper segment. It's the port number 80. We would like Apache to listen on that port 80, which is already defined in line number 6. So I am going to use another declarative method called line in file. And what this does, as it reads line in file, it will modify a line in file and make sure that such a line is present in that file. So you're basically making sure that there is a line in the destination file present that contains this regular expression. Meaning, you need to have a line that begins with the word listen and contains a line that says listen space 80. This is the number 80. And you need to have a line that says listen space 80. And such a line should be present in the file called destination, which is this file. It is the Apache ports configuration file. I want to make sure that there is a line in that file. So go and edit your configuration yourself and make sure that it contains this line. And when you do, you restart Apache like that. Another one. When I would like to have a line in file included in the destination happens to be etc Apache 2 sites available 000 default configuration. This is, by the way, the default configuration of Apache, which is what I would like to include, a reference to a virtual host. The virtual host I have defined is here. And this virtual host becomes associated with your example.com domain. And that is what we will be using in our example. So the value defined in our variables up on the top, as you can see here, is line number 7. There is a domain defined here called example.com. And I would like to have that domain defined in form of a virtual host in this segment. So when I do that, I'll insert a new line in that file. In this file, I will insert a line containing this detail. And then I restart Apache. Next, I would like to create a virtual host file. And the source for that file will be this file that I have already mentioned briefly here, the virtual host configuration file, this file. And I would like that file to be placed inside the destination, which is this location. .example.com.conf. So this domain is already defined in line number 7 up on top. So I would like to create and insert this configuration file in that destination. And then enable that newly created destination domain, which is example.com. And then you will like to clone a basic example HTML template available as a sample provided that I have provided already. So I would like to bring that sample and put that in the right location for Apache to show as a new website. And that is it. And this is what the entirety of that exercise that you did, a bunch of things that we had to do in Chef. In Ansible, you can do it very succinctly like this. And so when you run these things on your own, you will find the result. And I'm going to show you the execution result. Right now, I have the full file as is available here without modifications. I will also double check to make sure that I reset hard again. And now I will run Ansible one more time. So Ansible playbook, run the Apache YAML. The YAML reference we have here, the Apache YAML that you saw already, that file. I want to invoke that file and basically ask me for super user password again. So it'll do that action again. So it'll provide the password one more time. We need to provide the super user password because Apache is getting installed and we are dealing with port number 80, which is a reserved port. So you need super user privileges for you to be able to manipulate that. And therefore, this idea of asking for sudo password. And then we type the password and say enter. It will start doing its things. First of all, it'll install those things that we expect in the step number 11, line number 11 through 15, update the apt cache, and then install Apache and Git. It is taking a little time to update the apt cache, but actual packages are already installed, so it doesn't have to do them again. But it will skip those segments. I think it installed packages. This package was installed, this package was installed. It enabled Apache 2 on enabled mod rewrite, Apache listening on port number 80, Apache's virtual host created on port number 80, created a virtual host file, created an example.com domain, cloned a basic HTML template, and restarted Apache at the end. So we have seen a result of execution of this. And so what has happened as a consequence? Let's go see the consequences. The consequence basically is, now if you go to the Etsy location and in there go to the Apache folder, you will find that there is this configuration available called example.com. Where is example.com? Not here. Oh, sorry, it's not configuration available, it's sites available. Sites available. We have a new site available called example.com.conf. This new file was created on February 27th at 2 o'clock London time, which is this time right now here. And that is February 17th in that country. And so this is the UTC time at 2 o'clock in the night. So this new file got created. You will also see that this file got created. It contains exactly what we have in the virtual host configuration here, this one. The same configuration was copied over to that location, and it was replaced with the name example.com all along wherever it was needed. And so what does this translate to? It translates to the fact that we now have a site called example.com configured on our local machine. Now, can we see it? Can we open the browser like that and go to example.com and see it? Do you think it'll open? What do you think? Do you think something will open up like this when I go visit example.com? No, because example.com is a domain established for illustrative examples, and it is not owned by anybody. It is just a reserved name available on the internet. Go to example.com. This is what you will see. But I want to see my site, and I have happened to use the name example. I have happened to use the name example.com in my example. So how do I see my site? I know it is running. So I'll do a modification to my DNS, pretty much like this. And in the host file, I would like to change it to say that my local host, which is the machine I have here on the very top, it also is example.com. I made a modification to my host file. If you do not know what I'm doing, I'd like to elaborate that. So I'm basically modifying this file etc hosts, which is local to my computer. And in there, I'm saying my local machine, 127.0.0.1. This place is called localhost, by the way. This is a reserved IP address for localhost. And all I did was to say that in my domain system, locally to this machine, this address is also the example.com domain. I made an entry like that in my etc host file. This is the location, the IP address of every machine on the planet has the same IP address. It is the address of home, this machine, or this machine to be specific. So now I have ping example.com, and you will see ping's localhost right there. Because that's what I did. I created a new entry for my example.com domain. So now I can go to the browser and refresh. And it says what it does. Now, where did this come from? It came from our step here in this playbook. We have a reference to that in which cloning basic HTML template. So it cloned some template from some location. The location happens to be this repository, Ansible Apache site.git. And it was able to clone it and placed it in the right location. The destination happens to be this location. The destination happens to be /var/www/example.com. That location is example.com, which is defined in line number 7 up on top here at the very top. Line number 7. Oh no, yeah, 7 here. Domain is example.com. So you can see that same file showing up if you go to var www, and you will see it right there. There is an example.com, and in there you will find that index HTML, which has greetings, Cloud Genius. Looks like you successfully cloned this Git repository, and a picture reference. That's what you're looking at here. If you visit this, looks like you successfully cloned this repository. So the site shows up. Now, if you open up localhost directly, you will be greeted with a default page, which you saw from a previous exercise. So you run this exercise before, and we have modified the default HTML page to show you that Chef really works. And that's an entry that you will see because we have done a previous Chef exercise on this machine. Our default file changed. That's what you see here. Your Chef really works, but we did not run Chef right now. But this you will see only if you have done the exercise long ago with Chef on the same box, which I did. If you use it on a fresh OVA, you will not see this, but you will see Apache default page. We have configured a separate host, and that is what you see here. So let's recap what we did in terms of what we accomplished in the outcome here. Back to our browser. So I'm heading there. Where is my web browser? Here. And in that repository that I wanted to show you, so looking up that repository here. This is the folder structure that we were playing with. It is available on GitHub, by the way. And we saw this Ansible configuration. It has a reference to this file called hosts, which is a indicator that I will be using that file as my file containing my hosts. Back here, you can see that same file here containing only one entry called localhost in the group called Apache. You will also see the same thing again in the YAML file, which is the playbook file, which is what we have described here. And it did exactly what we discussed already. There are tasks defined, 1, 2, 3, and all those tasks. You see that when you execute, where is that? The virtual machine, where did it go? Here. So when you run that Ansible command one more time, for example, I'll go execute that one more. It'll do nothing, basically. It is idempotent, so you know that it'll do nothing. And I will run Ansible one more time, and it will quickly do nothing and come back saying, yeah, it did nothing. And so this thing that is doing right now is the updating action, which takes time, updating apt cache. And that part we can remove and speed up if we want to. But apart from that action, which is the update action, everything else is green colored, meaning it did not do anything. And so only change thing that happened was the update part, which is included in the install packages action. But all other actions are green colored, meaning it did not do anything. It was okay already to begin with. The only change that we did was the install package action, which included an update action. So if you now go back here and say, don't update, please. So say no to updates and save, come back here and say, run Ansible again and run Cloud Genius, and it will quickly finish up. And you see nothing changed. So no changes. All of them are green colored. And this is an example of what I call idempotence. So it is running the same thing again and again, and you will have your outcome that you have defined accomplished in your browser, which shows you example.com with the page that you expect to see, and all of it is up and running. We can play similar examples like we did before and go destructive and try to kill something. For example, let me go and identify those processes for Apache. And that is, and so these are the guys I want to kill. This number and the cancel. that number of 6549 I want to kill. So I'll killing 6549 and its brothers and sisters, 6552. Why am I typing wrong keys? Oh, okay. 6552 and 6553. I'm killing everybody else. Now we have Apache dead, which means this guy doesn't work anymore. And we can run run Ansible one more time. Like this. So you've seen the idea, you know the concept already. You've seen it before in Chef. Same thing in Ansible. And you will see one action will be yellow, everything else will be green. That action was to enable Apache. It was killed, so it was enabled again. That was changed. Everything else is green colored, and that is because I killed it. So now it is back to life. You can see it back to life by just reloading the page and it should show up. Concepts, the same things apply, except this is Ansible that was Chef. I think I finished the exercise, I suspect. There are some more apparently. Let me just quickly zoom through. And did I skip anything? Yeah, I'm basically uninstalling Apache also. So yeah, you know that. If you do not know what I'm talking about, I'll just illustrate that point, which is I want to uninstall Apache. So sudo apt-get remove Apache 2, get rid of it. Not remote, but remove. And so it is removing it. And I'm also uninstalling all the dependencies there. So something like this, sudo apt-get auto remove. So I'm completely eradicating Apache from my system, which means it should start failing now. And I refresh and I see nothing. Now I come back here and run Ansible one more time. And you will see that it will do the action of install and then enable, and all those things will become green, except one will be yellow. And that is this item of the install packages action. So it installed those packages. When I killed Apache, it was the enable action. When I uninstalled Apache, it was the install action that was yellow. So it appropriately knows what to do, what to fix, and is able to operate. Ansible does this with the usage of what are known as Ansible modules. And I'll show you where they are and how to find them, how to make use of them. They have an extensive library of these things called Ansible modules. Ansible modules are available in the documentation page of Ansible. Excuse me. In this site, you should stay focused on the Ansible documentation, not the tower side, but the Ansible documentation side here. That's where you will find a bunch of modules. And here is a complete index of all the modules available. And it's growing, and it is still a very large collection. The modules we used are in this list somewhere. And so it's a huge collection of things already available for us to make use of. And all we need to really do is look at a specific example. For example, let's say I used this module called apt to install packages. So let's go read what apt does. So I'll go back to here and search for Ansible apt module. And you will find the results showing you exactly how to use the apt module. So here is the module called apt that I use in this example here, line number 12. And I will go Google search to go straight to the point where the apt module is described and scroll down to the examples of how to use it. And here are them. Here are the examples. So example usage is very simple. The name, you provide whatever something you write in English language, use the name apt for the module you want to use, and install foo. Foo becomes the name of a package. More examples. Name something in English. Apt is the module to be used. I want to use Nginx latest version installed. and update the apt cache and get the default release from Squeeze backports. This Debian Squeeze is the latest version of Debian that is available. So if you want to get the latest versions of Debian installed on Jessie version of Debian, you use the backports. And that's how you can specify a previous version, sorry, a newer version installed in an older version of OS. Excuse me. That thing is called backports. You want to install Java in your computer, open JDK, you just name it like this and say apt install this thing, get the latest version, and it'll do it for you. And so the way to describe this thing is basically a very systematic way of writing. Remember this dash to begin with, followed by one indentation here for the apt and two indentations for the name, state, and install recommends. That indentation is critical. You see that I'm doing it already here. One indentation, sorry, two indentations. These are three indentations here for apt, 1, 2, and 3. This is 3 again. This is 4, 1, 2, 3, 4 indentations. So you have to really be very careful on how you write YAML, how you write Python when you do, and you will write some of it. But stay focused on indentations. It's a critical thing. Do not miss on that. If you miss on indentations, YAML will not run, Ansible will not run, everything will go bad. The reason why YAML and Python is actually succinct is because of indentations. You will notice that the way of writing actually makes a lot of sense because you're saving space and expressing your ideas in a much better fashion than writing something like, say, for example, this. You can write it like this if you want. Like in some other languages, you will see these notations of like that. Get this, get that, and then put that in curly braces. And so you've seen some structure like that in other languages. What Python and YAML do is they get rid of these opening and closing references completely by putting together appropriately indented code blocks like that. And if you are able to put like this, a structure like this, you are able to write with brevity. And that is the beauty of Python and of YAML. And so you need to remember the indentation aspect that I said, because you will run into trouble if you accidentally type one extra space or one less space or one extra tab or one less tab. It will not work. You should always validate your YAML if you're running into trouble. Having discussed this, let's see if there are more examples on this site right now on here. I think we just finished that example, but we'll do more. So in a sense, I think we are about to start a next example. So we will describe what this thing is and then proceed along. So this is the next example, I think. We just finished that other example, which we just ran. In that example, what we did was we defined, or rather used a ready-made place where we have ansible.cfg called out. We had a playbook called Apache YAML. We had a hosts file, and this configuration said, I want to use this file as my host file. And what this host file contains is a collection of boxes collectively called Apache. And in that collection, we had only one item called localhost. And so when you run this playbook, it will target your hosts and run the play. When it targets that host, which is only this one host, it will run the play on that box. If you want to run the same exercise on a remote machine, you should put the IP address of that remote machine here. So whatever that IP address will be, if you put that IP address, it will then run on the remote computer, provided you have the ability to SSH into that box. Like that. If you can connect to that box remotely, it will let you run the same play on a remote machine, and you will be able to basically run the same thing, same idea. And that is how our first example of Ansible play was. Now let us see a couple of other things here in this example, which is the next one, is to be able to, let me quickly read this example. So I want to stick to the example and make sure that you know this thing called Ansible runs are idempotent. Very similar to Chef runs, they're also idempotent. And there is a question that I think I already asked you, so I'm skipping that. Next one. I think I already discussed this. Ansible is agentless. What does that mean is that we have nothing running on the target machine. So you have a machine in the cloud. You don't have any residue process running on the box here. There's nothing, literally nothing. Whereas in case of Chef, you have something running here as a third-party piece of software, Chef client code that runs every so often, and it runs here, and that is an extra residue sitting on the box, which some companies do not like. Some organizations do not want third-party components sitting on the boxes, and they don't like this residual element sitting and installed on all the boxes in the cloud in all their infrastructure. And therefore, some people actually prefer Ansible because there is no such thing that needs to be sitting on the box installed from outside. So you are better off in that direction, is that you're not even allowing anything to come into your cloud to begin with. And so you basically thereby reduce vulnerability because you don't have anything, so there's nothing to worry about, nothing extraneous to worry about. So you just begin with just enough OS, and you don't have to have something like Chef client installed because all you're using is the built-in functions called SSH, daemon, and Python. One thing I would like you to remember is that Ansible currently is configured to work with Python version 2. Whereas you will notice that newer versions of Linux do not have this Python version 2, but they have Python version 3. And in that case, you will notice that Ansible will not work. So there are two ways to resolve this problem. Newer Linux use Python 3, Ansible still uses Python 2. How do you resolve? Two ways. One, install Python 2. Second, make Ansible use Python 3. Both are possible. Newer versions of Ansible like 2.2 or something will be able to use Python 3 provided you tell it to use Python 3. Otherwise, it will go use Python 2 and say, I cannot find Python. And the first option is to just install Python 2 on the newer boxes that do not have Python 2 to begin with. That's a change that is eventually going to clean up over time. Ansible will start supporting Python 3 by default, and newer Linux computers will be happy together. So occasionally you will find that problem you will run into. You will also see that the two differences that I think I did not mention is this idea of push by default versus pull by default. And I would like to describe what that difference is between Chef and Ansible. And the idea here is that you are able to push Ansible changes onto your cloud. So these are machines in the cloud that you have, and you are sitting here and you are driving the changes, you are pushing them over to the cloud. That's the way Ansible typically dominantly works. Whereas in Chef, the idea is that you will have these guys, these boxes, have them run Chef itself. So when Chef client runs, it pulls the kitchen. from the chef server. And so that pull versus push difference is something to remember and understand. There is a case in recent history in which Revenue Canada, the IRS of Canada, they ran into a problem where they ran into this thing called heartbleed. Have you heard of things like heartbleed as a bug in OpenSSH? Have you heard of this thing? So this heartbleed, it had a bug in OpenSSH versions in version 101A through F. It was fixed in the version G. It had the fix. So these things were bad. This thing was good. The version G 101, sorry, I should say 1.01G was good. So because of this bug that existed and nobody knew except some people who exploited it, found out that there is this OpenSSH vulnerability. They exploited it in form of heartbleed bug and eventually took control of Revenue Canada's computers. In fact, it turned out that a teenager was controlling Revenue Canada's computers. So Revenue Canada heartbleed bug. And you can see this guy who was basically a teenager at that time. This kid was controlling the IRS of Canada at that time, 19-year-old guy. And why am I saying this story to you? The bottom line is, if you have your infrastructure in your company controlled by something like this, OpenSSH, and you are specifying the word latest and saying update apt cache yes. If you have a setup that works like this, for example, let me clean up like this. If you have a setup like this, all you can do is run Ansible one more time on demand on a push, and you can update your 10,000, 50,000, whatever servers you have, all of them update apt cache and bring your OpenSSH server version to the latest version available at that time, specifically the version 1.01G. We did not have the vulnerability anymore. And that is not how Revenue Canada was set up. So they took, I think, a couple of days for them to fix that vulnerability. In the meanwhile, this kid was able to take control of social insurance numbers from Revenue Canada. 19-year-old from London, Ontario, facing 16 new charges. That's a news item. And this happened because they were not using tools like Ansible to update themselves quickly. If you have this method of operation, and if you install your infrastructure in a fashion like this, and you're able to update your cache and get to the latest version by run of a playbook, you can then update your entire infrastructure for your organization in a matter of few minutes, as soon as you discover that there is this vulnerability in place for a package that you use, and you are stuck on one of these versions, the bad versions, and it'll take you, I don't know how much time for you to update all your machines in your organization, in the Revenue Canada organization. Unless you manage through automation, it is practically impossible for somebody to update apt cache on all the boxes and update the version from the bad to the good one systematically, without fail, on 50,000 boxes. You can do that provided you have a method described here. So I'm going to focus on that right now here. If you have all your boxes, so let's call it all your boxes, and there is my method of installing OpenSSH server as an example. If you do it this way, update your apt cache and get the latest version and run this play, you will be able to update and secure yourself from the vulnerability known as Heartbleed at that time. If you don't go systematic like this, it is impossible for any person to actually catch and prevent identity theft from happening like this person did, apparently. And that is what is the difference in using something on a push approach versus pull approach. The push versus pull approach comes into play primarily because you can push anytime you feel like. Anytime you find that there is a vulnerability in place and you want to address that, you can. It allows you to push the changes out to your cloud, which contains, I don't know how many machines you got there. They will all be updated and you are able to prevent your vulnerability situation, as opposed to a pull approach, which is dependent on the fact whenever chef will come and run. It might take 30 minutes depending on the cron cycle you have or some other time, but you are leaving it for the pull to happen, as opposed to driving something that you would like to have immediately done. I want to do something right here, right now. I can just push. And that push method of operation has its own benefits. And I just illustrated you one example of how it can help and how it was used by other organizations, but unfortunately not by Revenue Canada. So they ran into problems, as you know. So skipping forward, I think the exercise starts in this step. What we are doing is basically getting a machine in the cloud. This time we'll run a slightly different exercise. We'll have a machine in the cloud ready and use that machine. You know these things. I think it is written down as if you don't know, but you know how to construct a machine in the cloud. So I'm skipping forward, and you need to make sure that your machine contains Python. If it doesn't contain Python, which is very likely if it's a newer version of Linux, it will not contain Python version 2. So I will now go to DigitalOcean, get a machine from there, and when I get a machine, you will find that it will not have Python 2 by default. It will have Python 3. So if I say, go get this machine, get San Francisco, ID RSA, and this is my test server, for example. That's the name I will give, a name, create. So I get a machine created, and I will log on to that machine as soon as it is ready. And what I will see is that machine, the test server machine, does not have Python 2 because it is a newer version of Ubuntu and it has Python 3, not 2. So you will run into that problem if you run Ansible without making any changes to it as is. That's the problem that I already mentioned. So the machine is now ready. We should be able to grab its IP address and go back to our virtual workstation. And here, closing out on this, don't save, and close. And back to our exercise. Here, we will like to check whether that machine has Python or not. That's what I intend to check. So I will go to that machine. Where is the machine? Here. And open a terminal, connect to the machine, and find that it does not have Python. Totally expected. So we'll say Python -v, capital V, and it doesn't have Python. So we have to install it, without which we cannot proceed forward unless we ask Ansible to change to Python 3, which is the other way of doing things. So right now I'm installing Python right here on this box by saying sudo apt get install Python, and just the minimal version, not the full version. So I'm installing that, and now we are ready with Python on that box. So we can use Ansible. So it is installing right now. Ansible version 2 should be ready, and it shows that it is ready, which means we can come out of this box back in our workstation. And we'll proceed with the exercise now that we have installed Python minimal. We should be able to configure with this box and play with it So the way to start building and start doing something will be to begin with creating a folder, basically. And so here we have a new folder constructed, and we enter in that folder, go in that folder, we find nothing right now. We'll open Atom editor in there and get ready to create something in that empty location. And so that is our plan as we go along. We'll back here. We'll make sure that we are able to construct a file called the hosts file. As you saw in a previous example, we have to create a file called hosts. And the idea behind this host file, which basically contains this one line, that's what the host file will contain. And it is a reference to the box that you have in the cloud. So in the cloud, you have a bunch of machines. This host file will basically contain a pointer to the machine. You will also have a playbook and a host file. And you will play the playbook against the target. And the host file will tell exactly where the play gets played. So this hosts, you have to create a file like that and put this line in there. What this does is that you have a new file here. So new file, paste this line, save it in the folder, and call it the hosts file. As simple as that. Here we have this name, and then the Ansible SSH host needs an IP address. So we'll put that IP address right in that location. And we know that the Ansible SSH username for DigitalOcean happens to be root. If it is some other cloud, we'll use that other name. So say, for example, Amazon, we'll use the name Ubuntu. If you're using Ubuntu OS, if you're using some other OS like Red Hat, you will use EC2-user. In Amazon, in Azure, you will use your name, but we are using DigitalOcean, so you'll use the name root. We have to replace this address with the actual IP address. So we'll get the IP address from here. And place it in the right location, like that. Now we have an entry. The entry is the only entry we have in our hosts file, which contains the name of the machine, the IP address of the box, and the root username. That's the entry for this host file. Ansible still does not know what this file is. So you have to tell Ansible by defining a configuration. You have to tell Ansible CFG file, basically, that my file is that file, which contains the list of hosts. So we'll get to that. But for right now, let us see if we can connect using Ansible, connect to that box, just as is. So we will attempt to connect that box. As you know already, we can connect SSH very easily. You can say SSH root at IP address, and it should connect to the box already. And we come out. We know that already. But I want to make sure that we are able to connect to this box using Ansible. So what I want to be able to do is say that Ansible connect to the test server and ping it, or use the ping module. It says, I don't know what this test server is because you did not define Ansible configuration. So you need to have a file called ansible.csv that tells this Ansible configuration that the host file is actually a file called hosts. So we need to create a new file called ansible.cfg. So we'll create that. And in that file, we'll write a reference to tell that my host file is hosts. This file. Now it will know that my Ansible host is that box. And it failed again for, I think my Ansible configuration is incorrect. This configuration is incomplete. So I'll go and make sure that it is correct by reading an example. From the first example we had was this one. It had an Ansible configuration example. How you write is a specific method. We have the word defaults specified before that. That was missing. So I'll bring it back here and write the word defaults and then save it. I think that was missing. So close back here and run Ansible again. it will attempt to connect to the box with the ping module, ping the box, and report back whatever it happens, whatever it says. It says, did I change something in the box? No, I just pinged it, and the response was pong. You can see the ping response comes back with a pong reference. And that ping pong you can keep doing with the box that you define, this test server. By the way, we are running right now, we are running Ansible without a playbook, using it in ad hoc mode, just casual mode of running Ansible. The command that we ran was Ansible. The reference target we are playing against is the name test server. How will it know what test server means? It will look at the Ansible configuration. Where is the Ansible configuration? It is right here. The Ansible configuration says my host file is defined as the file called hosts. Okay, so what does the host file contain? It contains a line. The line has a reference to a name, an IP address, and the username. So it knows these details from the host file. And it knows the details about the existence of that host file from the Ansible configuration. So it is a little bit multi-level references. If you see, there is a reference to Ansible CFG, which refers to host file, and the host file refers to a file called hosts. And then the hosts file contains a reference to a server with an IP address and a username. And then you are able to just identify it by the name and ping it. This ping is a module that you're using. -m is a module reference. You can basically execute any existing modules that you will see in the Ansible modules documentation here. You can run any of these modules. You have a large collection. You can run any module that you like and execute that particular module against that particular target. For example, this module is a command module. You can let you execute any command on the remote machine. So say, for example, the command module is this. So we should be able to run that command, I think, pretty similar to something like extraneous arguments. I think I must have typed something differently. This is not how it's supposed to be typed. But the command is probably a quote. No, I think I'm missing how to execute the command. So I'll skip that part. But bottom line that we have in this example is we are running Ansible ad hoc, pretty much like this. Ansible, give it a name of a server, and play out something with a -m ping as an example. More examples coming up on the same idea, which is to define the Ansible configuration, which we have begun already. You can summarize and simplify your host file by writing commonly used variables again in a common place. For example, if I expand my Ansible configuration here and make it a little bit more elaborate than what it currently is and go something like this, what I'm doing is adding these 3 new elements here. And what they do is let me define my root user already as a configuration option. So since I have it here, I don't need to have this root user mentioned already. I can strike that. Since I have already taken care of in the configuration like that, I don't need to specify it here. You will also notice that this idea of host key checking is false. And what does that mean? It means that if you have a known host file which is missing, or if your host is changed, for example, those issues that we occasionally run into when we are forcing ourselves to delete the known host file entry. That entry, if it is gone, you typically don't run into problem when you're creating the machines again with the same IP address on a different machine. The conflicts of checking host key is where you typically run into issues when you're trying out something or experimenting with something. And that is where this line number 5 comes in handy because it refuses to check. So in production mode, you want to enable it to be true, but for testing and examples, academic examples, you can leave it as false. If you say true, it will not successfully execute if you happen to have the machine change its fingerprint. So if you say right now, it will say, do I know this machine? And you have to say yes to it. And then it will say ping pong success. Now if you destroy the machine and get this different machine with the same IP address, the key is different, it will fail because the host key checking is true. And we can make it false to make the policy relax a little bit. That's the idea behind this configuration example. And like this, there are a ton of things you can configure and go along as you read the documentation for Ansible configuration as we go along. So the idea would be to simplify things in a collection of a folder that you have here, for example, is the Ansible configuration. Will collect all the commonly used defaults within your project. Like, for example, this project that we are dealing with, you will collect them together in the configuration and simplify your overall description of your product. And then you can add a YAML file to this. Say, for example, I will say create a new file and place the Apache YAML here. And so I can save that Apache YAML pretty much here, just like that, and bring it from the other example that we had, which is here. In this example, we had the Apache YAML. So we can just reuse that YAML file, the playbook that we had created already. You can just copy it and bring it here, paste it here, and play the same play. And it will now go and run on this host, which is the Apache host, which doesn't exist here. So you have to call it out by name in form of a group. So let's say we call it the Apache group. So pretty much like that. Like we had before, we had the item called localhost in here. This time we are using the name test server for a remote machine out there. Very, very similar to what you saw before in this example, where we had our host file reference to the Apache group, which contains only one machine, the local host machine. In our current example, we have the group called Apache containing one machine, which is a remote machine. And now if you run this play, it will expect a couple more files here. For example, this virtual host file is expected. So we don't have it locally. We can bring it here from this Ansible first run, bring this virtual host file that we have here in the example. We can copy that over and raw copy and bring it in a new file like that, save, and place it in a file called, what was the name there? The name was virtualhost.conf. So that's the same name we have to use. This name, we have to use the same exact name in this location and save it. So we now have the virtual host file ready. We have our Apache YAML ready. We have our host file ready. And so this folder will be able to operate on our target and make that target work like an Apache server for us, provided we are able to run and execute this particular play. So when we run this play, what will happen? We'll have an example.com domain constructed. We'll install Apache, install Git, enable Apache, mod rewrite, open a port, create a virtual host, and also insert a virtual host file, which is the file that we have provided already in this example, virtual host conf file. We'll enable that particular and enable that site called domain, which is the example.com domain. We will now enable that particular domain configuration, restart Apache 2, put in a basic HTML template, and then at the end defined a handler to restart Apache. So if you now execute the same play on the same target, we should see the same result happening on the cloud. For example, like this, Ansible playbook, Apache YAML, and off it goes. So it will do exactly what we did in the first exercise. We did it locally. This time we are doing it remotely. It is running the Apache YAML playbook, and it just magically knows what to do where. How do you think it finds out what needs to happen and which location do we need to target? Do you know how it figures out to go to the right spot and do the right thing? I just said Ansible playbook and then said Apache YAML. And it figured out it needs to go to the right machine in DigitalOcean and all that good stuff, and is able to do the things that we wanted it to do. And it did 6 changes. Happened already on the target. It was able to figure out to go to the right location, even though we did not specify, because of Ansible configuration. Ansible configuration said that here. My host file is the file called hosts, which is this file, by the way. And here I define my Apache group containing one box called test, which has this IP address. So when I run this play, I run it on the host collection called Apache, which means I'm running on the test server. So it knows to go there. It knows to connect using the server, using the root user here defined, using the private key I have here. And now when you see the result, it is able to complete all those actions expected of it, and it reports success at the end. And that means that we can open that particular box IP address here that we have. If you open that IP address, copy it, open it in a new tab, what do you expect to see when I type the IP address? What do you see? What do you expect to see if I type like this? Do you see the example.com configuration? Or you will see Apache default? Or would you see something like here? What would you see? I'm opening that browser right now, and I'm going to example.com, and you see this GitHub, this Cloud Genius page, right? Custom page. This is what you see in the virtual machine from a previous exercise. Now, when I run it in a different browser, in a different machine, open it up by the IP address, what do you expect to see? Anybody? You will see the Apache default page. I did not put HTTP there. This is the Apache default page showed up. Now, if I go to example.com, you will not see anything that from Cloud Genius, but just see the example.com publicly available page here. And that is because example.com is not defined in my machine. So I need to go to my machine and edit my host file again. So pretty much like this. And add the entry for this IP address that I have here onto the host file like this. Sorry, not like this. Like this. And then call it my example.com. So basically what this does, this entry, what this will do is make sure that hold on, let me save that, I think. Hold on. I think something went wrong. Where is that? Huh? Hold on. Something went seriously wrong here. Okay, I think my projection stopped. Okay, projecting again. And so now I'm able to open that example.com domain one more time, and you will see the Cloud Genius page. And that is because I'm able to ping example.com and it goes to the DigitalOcean machine. If I remove that host file entry, it will again go back to the host example page just like everybody else sees. And you should be able to modify your host configuration on your machine right now, mapping to this IP address. And you should be able to see the same page, all of you, if you edit your host file like this. And that is a quick way to use Ansible in a local machine as well as a remote machine for a given playbook like you saw. And let's check. Oh, we already crossed the time. Okay, so I would like to pause recording at this stage.